All right, this is the Chapter 11 practice test. So the following, make sure you state any excluded values. We also call them restrictions on the variables. They all mean the same thing. For all these, factor everything possible. So, number one, you factor out the numerator. It is a difference in squares, so it is x plus 5. Over factors of 20 that add up to be x and x plus 4. Not a bad idea to double check. 5 times 4 is 20. 5 plus 4 is 9. It's all plus signs. It's not as crucial to double check, but if you have a minus somewhere in there, I double check. I just this morning caught myself earlier that I messed something up. I'm really glad I double checked. So anything that cancels in the numerator and the denominator, I should say anything that you have that is exactly the same in the numerator and denominator, you can cancel. So x plus 5, x plus 5. So you're left with x minus 5 over x plus 4. That is your answer. As far as your excluded values, x cannot be equal to what would make your denominator 0. And again, the place you want to do essentially is what would make your original denominator 0. But to solve that, we're going to factor anyway. So the best place to do it is after you factor, but before you cancel. Because that thing that canceled still is one of your excluded values. So x cannot be equal to negative 5 because that would make this first one 0. X cannot be equal to negative 4 because that would make the second binomial 0. So that is the answer. One really quick thing. Please remember, the only reason we can cancel, if you have the same thing in the numerator and the denominator, the only reason we can cancel is because they are multiplying. So the reason I say that is because every year if somebody, the first thing they do is they take out the x squares. You cannot do that because it's x squared minus 25 or x squared plus 9x. You can't do it if it's plus minus. This was x squared times negative 25 and x squared times 9x plus 20. They absolutely could cancel those. But since it's not multiplying, you have to factor it, which is essentially changing it into multiplying, and then you can reduce. Same thing people do out, so it's just negative 5 over 4, and it does not work like that because adding and subtracting. Okay, moving on to number 2. A lot of people have been struggling with one like this. It's just a greatest common factor. So between the 3 and the 24, you can take out a factor of 3. They both have a factor of 3. So if you take out a factor of 3, we have 3x, but we took out a 3, so we only have an x left. You had 24, but I took out a 3, so I have 8 left, because 3 times 8 is 24. And again, you should be able to work backwards and take this 3 and distribute it, and you'd end up with what you started with. Because again, this is, somebody told me, Mr. Hofer said, the anti-distribution, because it's the opposite of distribution, is a very good way to think of it. Then your denominator, factors of negative 32 that add up to be 4 are going to be x plus 8 times x minus 4. Again, double check. They do add up to be they add up to be positive 4, and they still multiply to be negative 32. So from here we have the x plus 8's cancel. So we have 3 over x minus 4. That is your answer. That's simplified. Your excluded values, again, it's what makes the denominator 0. X cannot be equal to negative 8 or positive 4, because that's what makes each one of those 0. Now again, if you aren't sure how I'm getting negative 8 and positive 4, you can also make those equal to 0. X plus is equal to 0. You'd subtract 8 from both sides. That gives you x equal to negative 8. That's why we got negative 8. And same thing with the 4. You could set it up x minus 4 is equal to 0. And last but not least, we have x squared minus 49. So again, a difference in squares. So x plus 7 times x minus 7 over, if you have x plus 7 squared, that is just x plus 7 times x plus 7. I have a couple people that started putting this as a difference of squares as well. So make sure you're being careful with that. The x plus 7s ended up canceling. So your final answer then is x minus 7 times x plus 7. And your excluded values are x cannot equal
-7 and -7. Well, you only need to put it down once because it's just one number. If you put it down twice, it's fine. What would make this one 0 is -7. That also makes this one 0. This is also a good time to point out, when we cancel out, when there's 1 in the numerator and 1 in the denominator, you only can cancel out 1 for 1. So there's 1 in the numerator, that only cancels 1 in the denominator. I've had a couple people that the 1 in the numerator, they cancel both of them in the denominator, and that doesn't work. That only works if there was 2 of them in the numerator and 2 of them in the denominator. So simplify the following, assume the denominator doesn't equal 0. Again, that is just a mathematical way to tell you that you have a free pass. You don't have to worry about the excluded values at all. If you're interested in a little bit more depth, I can describe that or talk about it with you. Won't take long. I already have in class. But punchline is what that means. If you want to ignore it, you can. Just make sure you realize you don't have to find excluded values. Number 4 is multiplying. So the first thing we do with multiplying, you're going to factor everything you can. So the first one, the numerator, I can take out an x. It's common factor. So I have 2 x's, I took one of them out, so I have 1 left. The next one I have an x, but I took it out, so I have left is 2. I'm looking for factors of -18 that add up to be +7. That's got to be x plus 9 times x minus 2, I believe. Double check. 9 times -2 is 18. 9 plus -2 is +7. So we're in there. And my numerator is x plus 9 times x minus 2. It's because x times x is x squared, and 9 times 9. Factors of 18 add up to 11. And x minus. A lot of people mess up. They usually put. But again, if you double check, -2 times -9 is +18. -2 plus -9 is -11. So, again, if you have anything in the numerator and denominator, you can cancel, but not only if they're in the same fraction, but also if they're in different fractions. So, for instance, this x plus 9 and this x plus 9 also cancels, because one's in the numerator, one's in the denominator. Or I've said it, one's in the top and one's in the bottom. And the reason I say it that way is because it's the whole top, not just one numerator. So once you do all this work, make sure you double check, because sometimes you get one of these that's hiding, and I've done this before where I do everything right and just miss it when I write it down. That's x over x minus 2. You don't need to worry about excluded values because we discussed that about the denominator. So the next one's another multiplying problem. So I can factor out a 5. That gives you x minus 2. And this one I factor out another 5. That gives you x plus 3. Multiplied by, I can factor out a 2. That's x minus 3. And in the denominator, I can factor out a 10. That is x minus 2. So we have an x minus 2 on top, x minus 2 on bottom. The x plus 3s don't cancel. One's a plus, one's a minus, so we can't touch that. Then there's a couple other ways you can look at this to do this. You could factor out the 5s, or cancel the 5s rather, not factor. So we cancel out the 5s, and then 2 over 10. You can divide both by 2, so that's 1 over 5. That's personally how I would do it. So you end up getting the answer of x minus 3 is the only thing that didn't cancel. In the denominator, we have the 5 and then an x plus 3. Now, the other way you could look at one, or just to make sure you know it's an option, if you messed up any of these monomials, or I guess I should say, just any of these numbers in front, color. Any of these numbers in front, if you mess those up, you could just go ahead and multiply like normal. 5 times 2 is 10. And then 10 times, or 5 times 10 is 50. And then look at this part, the 10 over 50, and then reduce that fraction. Sometimes I think it's a lot easier to notice what's going on when it's less messy and just put it in one spot. So if you do it that way, that's fine. Just make sure then you can divide both of them by 10, which means 1 over 5. So you end up with x minus 3 over 5 times x plus 3. Now moving on to division. Again, division is very similar.
First thing you do, or the first thing I would do is I would multiply by reciprocal. I would not worry about factoring anything. I would not worry about simplifying anything. I would do nothing besides rewriting everything except for making it multiply by reciprocal. Make sure the reciprocal is a fraction. Now, once it's multiplied, now I'm going to do what I did in the other problems. Now I'm going to start factoring. So I can take out a 2x from the first numerator. So 4 by 2 is 2. 2x is I took 1 out, so I have 1 left. 2 by 2 is 1. X I took out, so I have 1 left. The factors of 4 that add up to be 5 are x plus 1 and x plus 4. Multiplied by factors of 1 that add up to be 2. Some people don't know this one, but it's x plus 1 and x plus 1. Times 1 is 2, plus 1, sorry, times 1 is 1, times 1 plus 1 is 2. Go through that little piece. Reduce all the factors, so it just stays 2x. Same thing we did on the other two. X plus 1 and x plus 1 they cancel. 2x into 2x they cancel.
Nothing else cancels on this one. So your answer ends up, scroll down a little bit. Your answer ends up being 2x minus 1 times x plus 1 over everything in the denominator canceled, decide to be x plus 4. There are some people that ask if you need the x plus 4 parentheses. If you put it in there, that's fine. It doesn't make any difference. You don't have to put it in. Whatever you're comfortable with, I'm okay with. And number 7 is another division problem. So again, literally, I don't touch the fraction. I do nothing with that one. Make it multiplying, and then the second one, I don't factor anything. I don't simplify anything. I don't do anything besides flipping it, making it the reciprocal. Now is when I start factoring and working some things out. So factor to be negative x minus 1 times x minus 4. Those do add up to be negative 5, multiply to be 4. Okay, we're good. This is x squared. 1 times 1 is 1. So x plus 1, x minus 1. Then factors of 4 that add up to be 5 are now x plus 1 and x plus 4. And then we have x plus 3, x minus 3. So now I have an x minus 1 and x minus 1 that cancel. And x plus 1 and x plus 1 that cancels. That's all that cancels. Nothing else is the same. So I end up with x minus 4 times x plus 4 over x plus 3 times x minus 3. Now, if you want to multiply those out, you most definitely can. If you're good at difference of squares, you might realize that's just x squared minus 16 and x squared minus 9. But you certainly do not have to multiply any of that out. The only ones you really have to multiply is when we're doing adding and subtracting. You have to multiply out the numerators. But that's just so you can combine like terms, and that's really the only way to do it. So hopefully it's pretty obvious. That is your answer for this one. All right, moving on to number 8. 8 is one of them that we have a bunch of monomials. So I put one of these. We've talked about these since that first day. There's a couple things you could do. I know some people that like to reduce the 3 to 12 right away. You could also reduce the 3 to 12. X's, reduce the y's, same thing here. Reduce the 8 and 9, reduce the y's, then combine things. I just think it gets pretty busy pretty quickly, so I'm just going to stick with my original. First thing I do is multiply straight across. So 8 times 3 is 24. X to the third times x squared. There's 3 of them on the left, 2 of them on the right, so that means we have 5 total. 1y and 3 y's. Y to the first is 4. over 9 times 12 y squared. 108 is divisible by 12. So if I both of those by 12, the 24 and the 108, we just reduce that like any other normal fraction. And you could do that way in your calculator. Put the fraction of 24 over 108, hit enter. If you put it as a fraction, it'll reduce that. But if you divide both by 12, that's 2 over 9. X is on top and 7 on bottom. So if I take away, the only amount I can take away is 5. That's the highest amount. Because if I take more than 5, my numerator doesn't have enough to give. So I can only take away 5. So remember, it's got to be the same number on the bottom. So if I take away 5, I don't have any x's left on top. I took all of them away. In the denominator, I have 2 left. With the y's, if you take away all the y's from the denominator, 2 from top. So that means I have 2 left on top. That should be your answer. Maybe. So that's my mistake. I forgot this y. So in the denominator, that should not be y squared. That should be y to the 7. So the first part's right, the 2 and the 9, the x's are fine, but then the y's, y to the 4th on top, y to the 7th in the denominator, you can take away 4, that leaves you with 3 in the denominators, y to the 3rd. So again, there's just a lot going on to keep track of, so I apologize about that. Now going on to adding and subtracting, and this is where I think it gets more difficult, common denominator. So the first thing we're going to look at is factoring out our denominators. Don't worry about our numerators. So we want our denominators to match. We have an x plus 3. Oops, sorry, they both have an x minus 3. That's awesome. They don't have an x plus 3 in the second one. So multiply the top and bottom by x plus 3. It's always got to be like that, top and bottom. If you multiply by anything like this, it's got to be numerator and denominator. So I am left with 2x over x plus 3, x minus 3, plus 2 times 2x squared times 3 is 6x over x plus 3, x minus 3. Remember, that's your common denominator. That's what we found. So since our denominators are the same, we have x plus 3, x minus 3, and your numerator is in like terms. So 2x squared, we don't combine anything with that. 2x and 6x is 8x. That should be your answer for that one. All right, number 2. Don't forget, you can factor out a greatest common factor. So that's x times x plus 2. That's a savior x when I can factor out an x, which leaves me with x plus 2. So x plus 2's are so this one, the first one needs an x. On the bottom by x. This one needs a 2, multiply the bottom. Now they both have an x, they both have a 2, they both have the x. So x times x is x squared. 2 times x plus 2. And I forgot an x. Hold on. X. That's that. X times x plus 2. 4 and then 2 x plus 2. Getting x squared plus 4, 2x times x plus 2. Keep in mind, you cannot factor out the numerator. It's x squared plus 4. If it was x squared minus 4, then you definitely could. But since it's plus, that is as factor as it can get. Excuse me. I'm boring myself. Number 11 is a subtraction problem. Again, not much different than an adding problem. In fact, the only difference is I would change it to a plus and make the 1 into a minus. Not the denominator, just the numerator. But I think that makes your life a lot easier. 3 over, that's 4, so x plus 2, I believe, plus 4 times x minus 2. So this 4, this one needs this, so we multiply top and bottom by 4. This one x minus 6, this one needs 1, top and bottom x minus 6. Over 4 times x minus 6 plus negative x 1 over 4 x plus 2. So we just have to add our numerators. Negative 12 doesn't combine with anything. Sorry, hold on, I'm looking at my answer key. This is just what's happening. Most of you guys hopefully saw this at the very beginning. Just a really super small thing that I messed up on. I didn't mess up on any math. I just had a mental lapse. So why did I put 3 down? It should be 3x. This is 12x. So now we do have like terms. 12x minus 1 is 11x. That makes more sense. The 6 doesn't combine. And our denominator is 4x minus 6 times x minus 2. X plus 2. Oh, see, and again, I just did the same thing because when I was writing down the denominators really quickly, I just forgot that was a plus. I did it over here, so that was good. But that goes to show you, I mean, there's not really a good way for me to do it otherwise, but the fact that I have to talk while I do it and not just think about it, I make mistakes like that just because of that. I also don't want to make this a super long video, so I'm going a little bit quicker than I probably should. Those are all things that make sure on the test, make sure you are careful and double check. Sliding that to a plus, that changes both of these. Again, not the denominator. X plus negative x minus 2 over an x. Do the math, they both have this x, that's awesome, but they need x plus 3, the first one. So top and bottom, plus 3. X plus 12. We didn't change anything for negative x minus 2 over x times x plus 3. Like terms, our denominator, we could do that first, and it's just the same thing it's been for the other two. X minus x, 3x, and 12. So 3x plus 10 over x times x plus 3. All right, moving right along here. Now the next ones are very similar because we're solving, and the whole point of to get your denominators to be the same, and once those denominators are the same, we can completely ignore them. Again, it's not a bad idea to rewrite these or use separate paper to make sure you have space. So factors of 3 that add up to be negative 4 are x minus 1 and x minus 3. And again, I just know that so I'm trying to make myself a little bit of space. All 3 of these need to have, well, this one has an x minus 1, this one has an x minus 1, the other one doesn't, so it needs an x minus 1. So it needs 1. And this one already, so we're good. All three of them have the same denominator, x minus 1. It's equal to x minus 1 times x minus 3. Now go back and look at the numerators. So the numerators are 8x plus 5. We didn't multiply that by anything. X1, 2 times x, 2 times negative 3 is x times x is 2x squared. That was close. Two x squared minus 2x. Denominators are the same, so we can ignore them. We have x plus 5 plus x squared minus 6x is equal to 2x squared minus 2x. So it looks like a lot going on, but really it's different than what we've done before. Combine 2x squared plus 2x, the 8x minus 6. Now the beauty of this one is you might, well, Mr. Stuck, we're going to give me any with the leading coefficient that I had you stack for you with, and now there's this 2x squared. So you actually didn't, because the first thing you do is subtract the 2x from both sides, 2x squared. So it cancels, but over here it also cancels, because again, it's 2x squared. You're taking away 2x squared. It cancels for the same reason this one canceled. Oh, run out of room. What we're left with is 2x plus 5 is equal to negative 2x. Subtract 2x, subtract 2x. 5 is equal to negative 4x. 4 divided by negative 4, that's your answer. X is equal to 5 over negative 4, or again, obviously, negative 5 over 4 is also good. You can put it as a decimal, that's okay too. We'll erase that when we get to the number 15. Okay, we're getting close. Okay, short night. So, same thing as before. I know this is redundant, and I know some of you, if you want to skip this part and do it differently, you can. You're showing your work in some capacity. But I do think it's beneficial to have some space. Denominators to be the same. This is x plus 3 and x plus 3. So this is 3. So we end up, and actually this is where I start erasing some of this so I have some space. So distributed, we have x minus 3 over x minus 3 times x plus 3. X plus 3 over x minus 3. Sorry, x minus 7. Man. Whew. Is equal to 4 times x plus 3, x minus 3. So now the denominators are the same. So we have x minus 3 plus x plus 3 is equal to 4. When you combine like terms, 2x, don't add 3 to both of these. I've had people that do that. You only add 3 to this one when you're taking it to the other side of the equal sign to solve. Since it stays on the same side, they just combine to get 0. Negative 3 plus 3 is 0. That is equal to 4. Then divide both sides by 2. X is equal to, that's funny, I was writing a 4, but that's wrong anyways. X is equal to 2. Oh no. Whew, that was close. I cried, which is okay. I'm a little bit of a crier, so. Would have been super awkward in the middle of a practice test witnessing a full-grown man cry. Okay. So, moving on to these last 4 or 5 problems. I guess there's a couple on the back. But these problems, again, this is the last thing we learned, and these are certainly not easy, but they're definitely one of the easier ones we've done in this chapter compared to all the other ones. It goes back to the very first thing we did, the very beginning of this practice test. Here, but it's got a little sad face. We not top left. Anyway, if you look at this test, this is the first thing we did. If you look back at section 11.1 from our notes, this is the first thing we did. Simplifying these rational expressions where there was not multiplying or dividing or adding or subtracting, it was just one fraction. So, punchline. First thing to do, factor everything you can. And take out 3x, which is x minus 2. And the denominator, we're going to factor factors of negative 8 and 2, x plus 4, and x minus 2. The x minus 2, so that's our that comes up. We end up with 3x over x plus 4. So since the negative 2 or x minus 2's canceled, that red flag is that there's going to be at x positive 2. If anything ever cancels, that means there's a hole there for our purposes. The vertical asymptote for this is what makes the denominator 0. So the denominator 0 would be negative 4 x equals 4. Now this one's a little bit more difficult, and it's actually, I would say it's not actually more difficult, we just aren't as familiar with it. What makes your numerator 0, 0 while your x intercept? But what makes 3x equal to 0? Well, it's just 0. 3 times what number is 0? It's not 0. So that x is equal to 0. So the x-intercept. But that's all you're doing for vertical asymptote is where the denominator equals 0. X-intercept is where the numerator equals 0. The whole is anything that cancels. Now, this is not a good teaching thing because I'd rather you understand why we do it, but make sure you realize the good news is answers are x is equal to, and not only that, but all three of these answers, you literally just take the opposite sign. I guess maybe not the 0, but the negative 4. Vertical asymptote, positive 2 was your whole. So that's what you see. Okay. Thing, we'll have x minus 7. Factor to be 3, positive 4, and negative 1. So first off, nothing cancels. So the first thing I notice is there are no holes. Sorry, I was looking at how I typed this up. Because I typed it up really weird. Okay. Oh, I bet you I corrected that before I printed it. Okay. Sorry. So look at my answer key, and I was getting confused at how things were numbered. Okay. We're good. So there is no holes, nothing cancels. So just NA is fine. Or if you don't remember what those letters are, just put no holes or something, some description. So your x-intercept is your 0, so that's going to be positive 7. But the denominator, what makes that 0? Well, there's going to be 2 of them because it's a quadratic. There's 2 answers. So one of your answers is going to be what makes this first part 0 is negative 4. What makes the second part 0 is positive 1. On any of these asymptotes, x-intercepts, and holes, you might not have one. So even you might not have a vertical asymptote, so you could put NA for that one as well. Obviously not this example. But you might not have those 2 or 3. You could have 3 holes, 1 problem. For the most part, we'll never get more than 2 holes or 2 asymptotes or 2 x-intercepts, but it is possible. Just in our class, we won't. All right, last thing on back, we're going to match the function with the correct graph. So the x-intercepts, asymptotes, and holes. Find those for these first, and then I'll look at the graphs. This is x factors of negative 6 to add up to be 1, x plus 3, x 2, and 3 times minus 3. Ready? I know that's going to be a hole.
minus 2 over x minus 3. So our x-intercepts are 2. And our vertical asymptote. So 2, positive 3, negative 3. Right. Close enough. So that's number 18. We will check which graph that matches in a second. Number 9, it's already factored. There is nothing that cancels. So for holes, there is no holes. The numerator of 2. Y-intercept is what makes your denominator 0. So that's positive 3. 19. And the last one, factor out both of those. That's x minus 1 times x minus 2. That's x plus, no, x minus 1 times x minus 3. They multiply to be positive 3, add up to be negative 4. The x minus 1's cancel, so we do have a hole. At x is equal to positive 1 because it makes that 0. Your x-intercept is what makes the numerator 0. Well, the 1 canceled, so we have x minus 2, so that's x plus 2. X is equal to positive 2. And the last one, your vertical asymptote, is where the denominator is 0, which is x is equal to 3. Now, I think I mentioned this, but I'm pretty tired, just in case I didn't. It's not a good way to do this. It's not a good way to teach you to do this because I want to teach you why things are. But all these are x is equal to. I think I started saying it. Maybe I didn't finish. But also, they're all just the opposite of what they look. This is x minus 2, so that's got to be positive 2. Minus 3 is going to be positive 3. Minus 1 is going to be positive 1. So again, that's not a great way to teach you as far as to make sure you understand what things are or why things are. But it does work out. So now our graphs, and honestly, if you know how to find some of these, like if you notice, the hole is different for all of them. So as long as you find the hole, you're good to go. And actually, if you look, every single one of them is the same graph. Actually, 2 over x minus 3. X minus 2 over x minus 3. So they're all the same graph. The only difference is the hole. So that's what you can check. Number 8, the hole was at negative 3. So that's got to be right here. That hole is at negative 3. But just so we know, that that asymptote is there at 3. The x-intercept is at 2. Goes with 18. The one that doesn't have a hole is 18. That's A. Still has a vertical asymptote at 3. Or sorry, x-intercept at 2, which means 20 has to be C, but just double check, the hole is at 1, and there is indeed a hole 1, and again, asymptote is at 3, and x-intercept is 2. I was going to say, I knew there was one other thing. So if you have any questions, make sure you let me know. As far as I know, all the answers on the practice test and on this video are now correct. Obviously, I could have made a mistake somewhere. That is not uncommon. So if you have any questions, let me know. Other than that, thank you for watching and studying and putting forth an effort.